Welcome to everybody to this first transnational seminar of the Natural Project. This is just to show you the agenda of today. So today the title of the seminar is Climate Change in Cities, Urban Microclimate and Heat Adaptation. And basically we will have three main speeches by three invited speakers. And then we have, first of all, we have a welcome address by our project management team. And as a very brief introduction to the seminar activities and topics by me. And then we start with the speakers, with the invited speakers. So I would leave the floor to Marco, our project management team, that we start with the introductory welcome.
Yes, hello everybody. I think that you can hear me. Just a very short presentation, since as Katarina said, this seminar will be also available in the following days and weeks in the web, in YouTube. So I will say something about Natural Project, just a very couple of slides, if I am able to. Yes. Can you see it?
Yes.
Can you? Yes. Nature is a project financed under the program of IPA Interreg. The program priority is supporting a greener and climate resilient Adriatic Ionian region, and it is under the specific objective enhancing resilience to climate change, natural and man-made disasters in the Adriatic Ionian region. 11 partners are part of the project, they collaborate in the project. The project has a budget of 1,200,000 euros. The overall objective of the project is to enable policymakers to prevent the effects of climate change on different zones of urban areas, especially of flash foods and heat urban islands, by adopting nature-based solutions. The project will develop through 4 different work packages, and also through it was designed for follow a path of 4 different steps. The first step is information and building knowledge. The second one is collection and elaboration of data. Then debates with and engagement of stakeholders and citizens, and then joint strategy, joint action plan, and solution tested in pilot action. As you can see in the first step of the project, under the title of information and building knowledge, we are talking about project partner, policymakers, civil servants, professionals, and group of citizens will be informed and trained on the complex interaction between climate and the city as evidence-based knowledge for decisions, action, and change of behavior. And this is exactly what we are starting today with this first transnational seminar that is dedicated to our partners, but then it will be available also for citizens, policymakers, everyone that will be informed about this seminar, and then they can reach it through YouTube and other web site or social, etc. So that's all for my part, because we have very many important and technical things to discover. So I will give back the floor to Davide. Thank you.
Thank you, Marco. So I'm going to share the screen again. Always please confirm me that you can see my screen.
Yes.
Okay. Perfect. Okay. So I'm Davide Longato from the University of Venice, in collaboration with the other partners of the Natural Project, in particular Corilla. We are in charge, let's say, of organizing this seminar series. So I'm going to very briefly introduce the seminar activities. This is only the first seminar, but we have more to come in the near future. And I would also introduce a little bit of the topics of the seminar, and so we can start if okay, able to change slide. Okay, perfect. Okay, so as I was saying, this is just the fourth seminar of transnational seminar series. We have planned along the first part of the project to have 3 transnational seminar. So the first one is today, 16th of October. The second one, so we have a fixed date. Yesterday we fixed this date, so the save the date will be sent soon to all partners. That is the 31st of October. And then we will have a third seminar that will be in person. And this is to be confirmed, the location and date of the seminars. As it was already said, our seminars are also recorded and uploaded to be visible also after the event. Main topics that will be covered by this transnational seminar series include the relationship between climate change and cities, with a particular focus on 2 climate hazards. The one is heat, and in particular urban in Thailand, and the other is flooding. So we will see how these hazards impact cities and urban environment in general, and how we can act to enhance resilience and adapt to these climate threats, especially using the concept of nature-based solution. So we have this, let's say, umbrella concept that are nature-based solution for climate adaptation that will be addressed along the seminar in various, let's say, spots in various speeches, until coming to the more, let's say, practical implementation aspects of nature-based solutions. So how they can be practically promoted, for example, within urban planning instruments or decisions. Okay, just to cite again, the overall aim of these seminars is to share information, provide knowledge base to support the next steps that are planned during the project. So the identification of climate vulnerabilities and the definition of nature-based solution to possibly implement in the partner municipalities to address the climate vulnerabilities identified previously. So as we can see here, also from the title of the project, a very strong focus is on nature-based solution. So I prepare a very few slides. Probably most of you are already aware of what the nature-based solutions are, but just to remind the main topic of the project. So what are nature-based solutions in practice? So these are the 2 main definitions, one from IUCN and the other from the European Commission. So basically, without strictly reading the definition, we can say that nature-based solutions are some kind of actions that use the natural processes of nature or of ecosystems to address societal challenges. And these societal challenges include various challenges, including climate change mitigation, adaptation, human well-being, biodiversity, and so on. But along with let's say, with addressing the societal challenges are also solutions that simultaneously provide economic, social, and environmental co-benefits. So for example, a solution that is, let's say, planned and designed principally to tackle flood, to reduce the flood risk, if it is designed with a nature-based solution approach, can also deliver co-benefits, for example, air purification or urban Italian reduction, and so on. So we can say if we let's say split the concept into the two main words that compose the word nature-based solution, we have nature-based on the one side, so that is the use of nature and ecological function of green and blue infrastructure to safeguard or increase the delivery of ecosystem services. And on the other side, we have solutions, so that are action properly planned to resolve or mitigate a recognized societal challenge, also providing, as I said, other co-benefits. This is just an infographic, quite complex, but just to show you the different interaction between climate change, people, and nature. That is the core, let's say, the core aspect addressed in this project. So basically, people can, let's say, use nature and natural ecosystem and nature-based solution in general in order that this nature help them to regulate the climate and to adapt to the impacts of the climate. So nature-based solution, in this sense, has, let's say, a strong focus on the benefits that people can derive from nature. And the benefits that people can derive from nature are also the so-called ecosystem services. So this is just an example of a nature-based solution, so an urban green space that can provide a series of services, of benefits for people, such as regulating the temperature in urban areas, mitigating runoff and controlling flood, reducing flood risk, purifying the air, or providing recreation opportunities to the city, to the inhabitant, to the residents. So these are just some exemplary nature-based solutions that we can find in urban areas. So we can green roofs, for example, so solution installed in buildings, so green roof, green walls, or solution that are along infrastructure, for example, street trees, solution more addressed to also society to enhance the social cohesion, such as the horticulture in urban areas, and so on. But so how, let's say, the EU policies, so here are just some example on how EU policies are really pushing for promoting nature-based solution approach in Europe and in partner countries. So this is just some screenshot about some news. So the European Green Deals is well aligned to fast-track action nature-based solution. So we can see that nature-based solutions are really pushed, for example, by the European Green Deal, but more in detail into some strategies or policies. Green infrastructure and nature-based solutions are explicitly mentioned also in the EU biodiversity strategy for 2030, with a strong focus on urban nature-based solutions. So we can see some example. And linked to this, there is the recently approved nature restoration law that is, let's say, a key element of these EU biodiversity strategies, setting binding targets to restore ecosystem, including urban ecosystems, so including green spaces in urban areas. And finally, since it's one of the main topics of our project, so climate change adaptation, also the European Union adaptation strategy explicitly mentions the need of nature-based solutions for adapting to climate change and climate impacts. So what's today's focus? Today's focus on this seminar is on urban heat. So I have just one last slide introducing this topic before leaving the floor to the speakers. So urban heat, how, let's say, urban overheating, we can call urban overheating because the urban Italian effect in cities is when we have temperature in urban areas that are particularly elevated and are higher than those recorded in the surrounding rural environments. And this is caused because of the different factors, of course. Here we have some tables from European Environmental Agency reports depicting meteorological factor, morphological factor, or human factor that aggravate heat impacts and heat island effect. But we can, let's say, very simplifying the concept, we can say that cities that are covered by hardly covered by impervious material that absorb and re-emit the sunlight contribute to overheating of urban areas, so contribute to having higher temperatures in urban areas, especially dense urban areas, than the other land covers such as agriculture or natural ecosystems. And within the urban green, the urban areas, if we have pocket of green space, we can see also from this picture, from this figure, that in the pocket of green space, the temperature tends to be lower than, for example, in highly impervious urban areas. So with this last example in the image at the right, we can see a comparison between the degree of soil sealing in a city, here we are in Budapest, and the surface temperature recorded with satellite. And we see strong correspondence between high impermeability and higher surface temperatures, contributing also to higher air temperature and urban Italian effect. Okay, so I finished. So this was just to introduce the seminar activities and the main topics covered. So we have now 3 speeches. Okay, here there is the agenda. So we have a first speech by Domagoj Vidakovic and about the effects of climate change in cities. So we start from a very general introduction about how climate change, what are the climate change impacts and how these impact especially cities. And then we will move to, let's say, more technical, let's call them more technical presentation. So more focused presentation about urban heat, urban Italian effect, how the city structure and different ecological or architectural, let's say, factors contribute to the urban Italian effect. And then we have final presentation about a case study in which the urban Italian have been mapped and some mitigation strategies have been proposed with some indicators, let's say depicting the good effect of the mitigation strategy in reducing the temperatures in the city. Okay, so from my side, that's all.
Okay.
And yes, we can start with the first speech. Thank you, Domagoj. So I would say that okay, we are 2:25.
I'm trying to share the screen. Can you see it?
Yes. Not yet.
Let's see, slideshow. You don't see the screen?
No.
Let me see.
At least I don't see the screen. I don't know the others.
Share.
We don't see.
Not. No. I'm trying to see. You just click this share on the select.
Yes, I have the share screen.
Entire
Top
screen.
right.
Hold on. Is now better? Share.
Screen.
You don't see the screen, or you see the screen?
No, we don't see the screen.
No, we don't.
You have to push near the leave red message on the right top of the screen. There is a share.
That's what I'm trying to do. It gives me share,
Share, then you have to select which window to share.
Window.
Click on the window.
Chrome tab window.
Okay.
No, it's got the entire screen.
Now it's going.
You got it?
Yeah.
No, no more.
Do you see the presentation?
No, not more.
No.
Let's see. Share. Link to the slide, copy link. No, I'm trying to. I do that only in the meeting, not in the PowerPoint, right? The entire screen. Okay, but for some. Okay, let's see this. It for some reason doesn't allow me to share. Share. Window. Only gives me an option to cancel. I don't know why.
Or do you prefer that I share the screen for you?
Okay, do that, and because this will take too much time.
Okay, because you sent me the presentation this morning.
Yeah, so go and I'll just tell you
so...
when to go to the next slide, okay?
Okay, so
and now I'll have to adjust watching both you and the presentation, so it will. Okay, go ahead and share the screen, and I'll look at mine, and so.
So it is the last version, the one that you sent me this morning.
Yeah, that's the last one. Effects of climate change in cities.
Okay, I'm going to try.
That was a good idea to send it because we would. Yeah.
Can you see? Is this one right?
Yes.
Okay, perfect. So you said to me when to change slide.
Okay. Hello, my name is Domagoj Vidakovic. As you see, we are from Energo Data Creation Company. So go to the next slide. So just to say a little bit about us, I got my degrees in the States, chemical engineering, and then Master of Business Administration. We run small energy consulting and business company in Croatia. We also have 2 NGO affiliates that are active in EU funding. We also have a small affiliate in the United States, but it's not doing much at this point. Our main activities, as I said, are energy and business consulting. In energy, we focused mainly on energy audits. We've done more than 500 energy audits of the buildings since 2010. Now we are more into SecOps and strategies as we move away from that, and we are also active in EU funding. I know a number of you from other either Adrian or other Interact projects, whether we are partner or whether we are consultants. So you can go to next one. Okay, so what I was going to say, I had a lot of issues or dilemma what to start with, because just in the last 2 weeks since I talked to David, lots of things unfortunately happen to be very current in this environment, and I was doubting, do I want to put them, and I decided, although it might take away a little bit from shall I say theoretical part of the presentation, to put those things inside because they're real, they happen now, and some of them obviously are not in Europe, not in Adrian region, not even in Europe, but they affect the climate and urban areas very much. So as you know, I chose to put Hurricane Milton, which was just 4 or 5 days ago. It started as Category 5. Luckily, it went to Cat 3 before it landed, and but there was at one time real scare because it was supposed to hit the Tampa Bay urban area, which is home of 3.5 million people. Luckily, it went south, so damages are much higher, much lower, although they're still significant. But point being is, and I'll show you what would happen if that was direct hit later. But that's something we live. Unfortunately, we'll live it. So one that was I personally lived through. I was in Louisiana at that time, not in New Orleans, but this was before Milton and before other hurricanes. It's probably still the deadliest modern time hurricane in U.S. history. It's probably not the highest, because there was another hurricane in what they call a Labor Day hurricane in 1900 in Galveston, Texas, when they didn't have radars, so they had 5,000. But modern days, with all technology, all remember these pictures from New Orleans. I was checking number today. They're still talking about between 1,800 and 2,500 dead people, and they still, as of today, are classifying 100 people as missing. Okay, that was in 2005. Now we are almost in 25. We are not yet, but 20 years, and there's still some people missing. So that's you can go to the next slide. And unfortunately, Marco, sorry. So here is really recent, since I'll be cooperating with the International University of Sarajevo. This was really another event just happened almost a week ago. True, it didn't hit large urban areas like Sarajevo, but this is picture from Kiseljak, which is small urban area 20 kilometers out of Sarajevo. Of course, Jablanica and other places that got, there were more than 30 dead. There were some other issues other than floods, but this is also mainly washways and stones, but this is and mudslides, but this is what we are getting with the extreme weather. So, and now I'm coming back to Tampa. Basically, this is not so much about the hurricane, but this is we all know, and this is also part of the project. Some scenarios of climate change, and they've done Project Phoenix, which was simulating how would Category 5 hurricane hit the Tampa Bay area, which I said we had 3.5 or 4 million, depending how far you go, people, and they think it would probably wipe off most of the city if that hit happened. And they said, depending on who you take, that Tampa Bay is after New Orleans. New Orleans has specific problems even without the climate change, because it's below the level of the sea and it's surrounded by water. But New Orleans and Tampa being the most vulnerable to the hurricane hits. Luckily, last hit they had was more than 100 years ago, so they didn't have a modern hurricane yet. But it's more and more increasingly threat is coming, and unfortunately we'll probably see something close to this scenario sometime. So what are now more into theory, what are the key contributors to next slide? What are key contributors to climate change, and why climate change so much affect cities? So two main things are construction and transport. So key contributors to climate change are, and also greenhouse gases emissions, and also high density population. Problems that got out of that, obviously, we get overpopulation in the cities. We get water scarcity in the cities. Obviously, that leads to to the poverty in some cities, in some big cities, especially in developing countries, and he leads to illness, especially heat illness. So we can go to the next slide. So this is interesting. A consumption-based emission has a significantly more impact than a production-based emission in within the cities. But this is studying 85% of emission associated with goods within a city is generated outside of that city. Climate change adaptation and mitigation measures are necessary in the cities and outside the cities. And from what we've seen so far, obviously, we have to start today or even yesterday. So that's one of the reasons why we have this project, and why this project is only a small part of the efforts. And although we are, it's not, we are trying to look at, it's not, definitely not, it is a city problem, but it's not a local problem. It's not even a national problem. It's not it's a worldwide problem, although we have to start solving in regional like we did here. So next slide, please. So what are some measures we can take to mitigate this climate change, or to at least make it more livable in the cities? So we certainly have to reduce with some more land for agriculture and not for buildings. Although this is not in the city, but it's obvious reforestation. I won't go into why and what we need with Amazon. And the other two things are also, especially for policy planners, transport efficiency and greening of the construction. And this all measures have to be taken in the cities, but also in rural areas, especially with the redistribution of land and reforestation. But they are all interconnected, and they cannot be taken by themselves. So some more measure. Next slide, please. Yeah. More measures, which most of the representatives of the cities at the present or experts know. I just listed them here, what we need to do to mitigate, but specifically in the cities. Obviously, bicycle infrastructure needs to be better. When I say bicycle infrastructure, some countries are better than the others. Bicycle infrastructure does not mean, like they do in some parts of Croatia, especially in Istria, that you organize races on the roads. It means that you organize paths where people can use it safely rather than cars. Obviously, we have a building retrofitting, so that you use all energy efficiency measures can be from heating, from lighting, from AC to everything else. Then we go to district heating, moving district heating to more friendly or even renewable energy, depending on the sources. Public transit obviously needs to be more and more taken into the consideration, because it certainly helps having a reliable public transport, that people don't have to use the cars. I think the example that I read today, two opposite, Vienna is probably one of the best thing of public transport in Europe, but just two opposite side, Tokyo has 8 million subway riders, and Los Angeles on the other side has 4 million cars every day. So just two opposite examples. Then obviously on public transport, we talk about walkable cities. So it's walk friendly and bicycle friendly. Then we have, obviously, cities have, and that's what we are trying to do at some level here. Cities as a living lab. One good example is San Diego, and also other experimental measures that we'll take during this project or at least solutions. So that's next slide, please. So what are the consequences of climate changes in the city? As we already seen, hurricanes, we've seen more, although in Europe we are not as prone to especially in this area, Adrian area, we are not that prone to hurricanes, but in tropics, you've seen and especially like you'll have another problem like in Florida. Now it becomes a problem to insure your home because insurance companies calculating it's simply too much risk to insure your home against hurricane. Then, of course, we have the weather storm damages like floods, what we've seen in Bosnia, then mudslides, and obviously we have to take mitigation and adaptation measures. And unfortunately, we cannot start from the other, but we first, when you have flood or anything else like now in Bosnia, first you have to remove the consequences so people can live and then rebuild and implement climate-friendly techniques. But it takes first mitigation and then maybe moving to eco and energy friendlier cities. Now let's go to next slide. Heat islands, which is another effect, and this is I'm going to cover very briefly on that, but we need to know what it is. Heat islands contribute to the higher daytime temperatures, reduce nighttime coolings, and higher air pollution levels. Anything negative you can imagine, it's here. And it also, as I said, contributes to heat-related deaths and heat-related illnesses such as the general discomfort, respiratory difficulties, heat cramps, heat exhaustion, and non-fatal heat strokes. So unfortunately, it does affect the health, it does affect everything else. Next slide, please. So some heat island effects in the cities, which I think most of them are obvious. We have obviously increased the energy consumption because if it's extreme winter, you're heating. If it's extreme summer, you're cooling. So you're obviously taking more energy than you used to. Elevated emission of air pollutants and greenhouse gases, which is not surprising because now those two lead to I would say too connected, which is comfort, but compromise human health, obviously from heat strokes to everything else, from airborne diseases, and obviously all this leads to, I mean, more feeling, but compromise human comfort, which is obviously if the quality of life is falling, then your comfort is falling. Water quality is falling, so drinking water becomes issue scarce. So that's the problem. And of course, as we've seen, and I keep emphasizing that, we have extreme weather events from, again, hurricanes, floods. Now, it's true that we are better at predicting it, but it's true that we are better at predicting it, even mitigating it, but they're coming more and more. And next slide, please. So what we can do before to mitigate some of heat island effects. I mean, most of them are obvious, but as we said, reforesting, so increasing tree and vegetative covers obviously will give us more oxygen. Green roofs will help. Cool and mainly reflective roofs also will help. Using cool pavements, either reflective or permeable, and also smart growth practices from traffic, from city services, everything else has to be smart. And unfortunately, adaptation before mitigation, we first must adapt to the changes and prevent them from further effects, and then we can only mitigate. And next slide, and that would be everything from my side. Now I'm open to any questions, comments. As I said, I wanted to at first go more scientific and more theoretical, but unfortunately, I had more than enough, and I could cover a couple other hurricanes or even floods in Austria, even in Italy. We were in Marco will know. We were in Italy 2 weeks ago when there were floods in Emilia-Romagna. Unfortunately, I could cover this presentation with current events, just not going too far back. But I take Davide, I take leave the floor back to you, and if there are questions, I'm more than happy to answer it.
Okay, thank you, Domagoj. I don't know, maybe we have time for 1-2 questions, if there are, or from someone that want to share the experience in each city to the impact of climate change in each city, since I know that there are a lot of municipal officers here today. So anyone want to contribute? Or maybe we can say that we will have a final short discussion after the 3 speeches to cover all the topic and the issues.
Okay, if there are no comments, questions, I'll leave open towards the end of discussion, and I'll definitely now give floor to you.
Okay. Maybe Domagoj, I have just one small, no question, but curiosity. So since we are in Italy, and we know that, for example, the last 2 summers were very, very hot, and we had a lot of heat waves, and especially 2022, we have plenty of studies that in Europe we had let's say a peak of heat-related mortalities, especially in cities. So I don't know if in the IPA countries, how is the situation? How was the situation? If you still have this kind of problem and with kind of intensity.
Well, I am in Croatia, but yeah, I mean, Southern Europe, whether it's IPA countries or heat waves, are more and more common. There were studies, at least from Mediterranean maybe point of view, not so much from that. It might be too hot to go to Croatia, Montenegro, Albania, or Italy for a summer. We might end up going to Sweden or Norway for vacation.
Yes, definitely. Okay. So I think that we can move to the next speech. I have in the program the speech of Emanuele Naboni, but I think it's a little bit late, or I don't see him here, not yet. So he said to me that he was arriving at 2:50, that maybe it's a few minutes late. Maybe Marco, we can go first with yours, if you agree. So we can give the floor to Marco Noro, associate professor from the University of Padua, but I let him present himself. Okay. Thank you.
Okay, thank you very much, Davide. I hope you can see my screen now.
Yes, we can.
Yeah. Okay. So, sorry for this change in the order, but I'm presenting myself. I'm Marco Nauro. I'm an associate professor at the Department of Management and Engineering at the University of Padova. As I will describe later in my presentation, Padova is a medium city size in the northeast of Italy. And I work at the university. The University of Padova is one of the oldest, maybe you know, university in the world. And what I'm going to introduce to you is a work that we carried out some years ago, really over 10 years ago, as I'm going to describe to you, in collaboration with Corilla, so with Mr. Pierpaolo Campostrini, that is connected now, that I thanks for this opportunity we had more than 10 years ago to approach and to study this problem, this phenomenon, the urban heat island. As you know, urban heat island has already been studied mainly in big cities. These are some references concerning big cities, but concerning medium-sized cities, the phenomenon was really little studied, very little, and mainly in Italy, and so this was one of the reasons. We take this study more than 10 years ago. The context was the European project, the UHI, that was between 2011 and 2014, with the title Development and Application of Mitigation Adaptation Strategies and Measures for Counteracting the Global Urban Heat Islands Phenomenon. So there was a lot of partners, as you see in this picture, and Padova was, and the Veneto region was, where Padova is, was one of these partners, and Corilla was another one, and Emilia-Romagna region was the lead partner of this project. So within this project, I'm going to describe the work that the University of Padova with Corilla carried out within this project. The work we carried out was based on different steps, first step concerned the analysis of data of meteorological stations. The second and the third steps were the very labor-intensive steps concerning mobile service of the phenomenon, so measuring the urban heat island phenomenon in Padova, and in situ measurements. And I will describe you what we did concerning this work. And a final step was to propose adaptation and mitigation strategies by numerical simulations. For some specific, I will describe you one specific case, but we took into consideration two specific cases. I will present one of these. So concerning the first steps, the analysis of data from meteorological stations, we collected and analyzed historical meteorological data of Padova. The data was collected by the Regional Agency of Environmental Protection of Veneto and consisted of hourly mean values of dry bulb air temperature, so the temperature of air, and the wind velocity at 2 meters above the ground along a very long period, so between 1993 and 2012. And from this data, we calculated the monthly mean values of the minimum, of the maximum, and of the average temperatures, and then other quantities, and mainly the heating and the cooling degree days. We calculated the heating, the cooling degree days as indexes to have an idea of the trend of the more heat or more or less heat in Padua. We compared the data of two meteorological stations, one in the center of the city, the Orto Botanico meteorological station, and one in the countryside, so the meteorological station of Legnaro. Here the results. I go very fast with this first step. These are the monthly averages of the minimum of the difference between the air temperature between the two stations, meteorological station, of the minimum, of the maximum, and of the average temperatures in the period analyzed. And the second graphs is representing the yearly mean values of the same quantities. So the first graphs highlights that the urban heat island phenomenon is mainly present during night, is mainly evident during night, because as you see from the graphs on the top of this slide, the green curve is higher than the other two curves. So the green curve is the difference between the air temperature of the two stations of the minimum temperature, so during the night. And so during the different months of the year, obviously mainly during summer, you see that mainly there is a urban heat island phenomenon also in Padua, so also in a medium city size city in Italy. And the second graph are yearly mean values. So you can see that the difference in the maximum temperatures, so the red curve, highlights that there is a sort of trend in the values. So there is an increasing of the difference in maximum temperature, so during the day. And you see that mainly during the second part of the period, there is an increase of this difference between the temperatures of the two meteorological stations. Keeping together all this data allowed us to calculate the cooling degree days and the heating degree days that are two indices. That the first one, the cooling degree days, represents a sort of index of the necessity of cooling, and the heating degree days represent an index that represent a sort of need of heating. So we can see that mainly during the period we have a trend of increasing of the cooling degree days and a sort of decreasing or stabilizing of the heating degree days. That means that during the years we have more necessity of cooling the buildings, for example, and less necessities of heating the buildings. This is because of the heat island phenomenon. One of the reasons is the heat island phenomenon in the city. This was a very first analysis of the phenomenon from the macroscopic point of view, so analyzing very raw data, but we carried out experimental measure by ourselves. This is me and my colleagues more than 10 years ago, as you see, with black hair, not like now, but we measure some variables, so dry bulb air temperature, relative humidity of air, the solar radiation, the global solar radiation, the wind velocity, and the mean radiant temperature. This is a very interesting index variable, as I will show next in the results. Here you can see the instrumentation that we set up for the measurement, and obviously the global solar radiation was measured only during the daily transepts, and the mean radiant temperature was measured only during the nightly transepts, because the global thermometer, as you can see, the black sphere can be used on not with the direct solar radiation on it. And the wind velocity and the mean radiant temperature was measured during stationary measurements and not during the transept, obviously. So we did both measurement during the transept, so during when the car was crossing the cities, and measurement in situ. So for some specific sites of the city, we stopped the car and we did the measurements in situ, as I will show next. Okay, this is the instrumentation for the acquisition of data and storing the data. I go ahead to describe you the transept, so the path we think about it, and crossing, so starting from the northwest of the city, crossing the historic center, and crossing different fabrics of the city, so residential zones, less densely populated residential zones, and industrial zones, and finally the countryside, and to the southeast of the city, and then coming back along the same path. A very important thing was the data georeferencing using a GPS receiver connect to the notebook or some app on the phones. And the very important thing was the synchronization between the clocks of the notebook and the data acquisition systems in order to be sure of comparing the different data at the same hour in order to calculate exactly the phenomenon, the urban heat island phenomenon. These are the 8 transits we made. Mainly during the night, the evening and the night, as you can see from the hours, but 2 of the 8 transits were made during afternoon, so were daily transits. Here are the results. These are the results during the time. You see here the curves that represent the UHI intensity. So the difference between the dry bulb air temperature between the instrument on the car and the data measured by the Legnaro meteorological station, so the countryside meteorological station. So we can say that this is the urban heat island intensity. And these 4 graphs represent the nightly transepts in different dates. Here we can see one of these bigger size to better understand. And the red vertical line point when we turn back the car and come back to the start of the path. And you can see that if, for example, we look at the coming back path, so the southwest to northwest path, you can see that the maximum of the intensity of the urban heat island, so around 6 degrees Celsius, is in the historic center of the city. So you can see it in the picture, in the top picture. While the reference, so the minimum of the effect is in the countryside, as you can see in the picture on the bottom of this slide. We did also 2 daily transects, 2 daily surveys, and you can see here that the urban heat island intensity in Padova during day is largely lower than during evening or during night. So during evening, the urban heat island intensity was till 6 degrees, and during day it is around 1 or maximum 2 degrees. So urban heat island is a phenomenon, so the overheating of the air with respect to the countryside is a typical evening nightly phenomenon, not a daily phenomenon. Also, we measure the relative humidity of air. The data represented on the graph on the left. And by knowing the relative humidity and the air temperature, we calculated the humidity ratio of air. So, you know, the difference between relative humidity and humidity ratio. Relative humidity depends on temperature, while humidity ratio is the content of water in the air. So it's the content of vapor of water in 1 kilogram of dry air. So the graph on the right, the humidity ratio, is better representing the water content on the air. And we can see that in the center of the city, so okay, in this part of the graph, if we look at the southeast to northwest path, in this part we have a lower water content with respect to the countryside, as this is another reason of the urban heat island phenomenon. So the lower content of water in the air in the urban environment with respect to the countryside. So in the urban environment, we have a lower cooling effect of air by the evaporation of water vapor. We measure also the mean radiant temperature. This was calculated by this formula, okay, by measuring the global temperature by this global thermometer and the air temperature. But all this data were then used in one simulation tool that is Rainman, is a simulation tool created by Professor Matsarakis from the Meteorological Institute of the University of Freiburg. At that time, I don't know if Professor Matsarakis is still at the University of Freiburg. This is an interesting tool because having some as inputs the data and time of the geographic data, the topography, the data concerning the buildings, the vegetation, and the albedo and the sky view factors, as I will show now, and about air temperature, the relative humidity and velocity of air, and some other data concerning the clothing of people and the activity rate of people. The tool allowed to have in output the mean radiant temperature. So the mean radiant temperature is an output of this simulation tool, but also we measure these parameters and some other thermal indices that are related to the thermal comfort of people. So this tool was used to measure the thermal comfort of people in the urban environment. The sky view factors, the view factor is an input of the tool and it is calculated by the tool by means of pictures that you have to put in input of the tools. And these are the other inputs of the tool. So the topography, you have to describe the topography of the site, the obstacles you see from the point you are considering, and the sky view factors by picture from the point you are considering. So the Rayman tool calculates the different thermal comfort indices. The predicting mean vote is one of the most known thermal comfort indices. In this case, it is used also for outdoor thermal comfort, even if it is mainly used for indoor thermal comfort. And as you know, a predicting mean vote of 0 is the higher, the best value, because we have the lower percentage of dissatisfied people. This is from the Fanger theory. And so say that a value around 0, so conventionally from minus 0.5 to plus 0.5, is considered a very comfortable value representing a comfortable environment. And for the outdoor, other indexes were developed from the researchers, and the tool, the Rayman, is allowed to have in output the physiological equivalent temperature and the standard effective temperature that we have here, the definitions and the range in which the indexes can vary, and say that comfortable for the predicted mean vote is 0, and for the PET is around 20, and for SET is around 23, 24. So these are the results that we obtain in having in input to the Rayman software the data we measured in our in situ measurements, starting from the historic center of Padova. For example, this is via one street, Via Rinaldi is one street in the historical center, with very high height to width ratio. So H over the W is the height of building, the average height of building to the width of the street, of the road. So this is a very high for comparing with the other results value, and so we have here a very low sky view factors, as you see from the picture here. And for this case, these are the results of the different transepts so the different measurement we have. And in particular, I want to show you the air temperature in this line. Maybe I can have a laser, okay. The air temperature in different transepts. So for example, for these three measurements, we have around 29 or 28 degrees Celsius, and the intensity of the urban heat island effect is around between 4 and 5.5 degrees Celsius. But also please consider also the mean radiant temperature. In this case, so in Via Rinaldi, so where the H to W ratio is high and the sky view factor is low, we have a mean radiant temperature that is a parameter very connected to the comfort of people, so to these indexes. We have a mean radiant temperature very close, very near to the air temperature. As you can see here, we have a value very close, and also mean radiant temperature is also higher, 29 degrees here and 28 degrees here than air temperature. So in this situation, we have an PM predicted mean vote, for example, around 1.4 or 1.2. That means slightly warm, so not comfortable situation. We have a slightly warm situation. If we look at other situations, so other points of the fabric of the city that in which we do in situ measurement. For example, Via Pindemonte, as you can see from the picture, has a lower H to W ratio and a higher sky view factors. So this is the red point here and the point here in the picture. In this case, as you can see, the air temperature is slightly lower than in the previous case, and the mean radiant temperature is also in this case is near the air temperature. The urban heat island intensity is quite higher, around 5 degrees. And so also in this situation, we have a slightly warm conditions. But if we go to other situation, for example, in Via San Basilio, where this is a residential zone, but with lower H to W ratio and higher sky view factors, you can see that in this case, the mean radiant temperature is lower than air temperature. And the urban heat island is intensity is lower, and the predicted mean vote and the physiological equivalent temperature, so the comfort index are lower. So we are here in a more comfortable situation. And if we look at the industrial zones, so with larger streets and not so high buildings, so a lower H to W index and high sky view factors, we can see that in this case, the mean radiant temperature is definitely lower than air temperature, so 23.5 versus 27.4, and the predicted mean vote is around 0.4, so it means a comfortable value. Okay, in the countryside, obviously we have the best situation because we have sky view factors equal to 1, and the type of surfaces have a very different thermal behavior with respect to the urban environment. So in this case, we have obviously a lower air temperature, but above all, we have a lower mean radiant temperature than air temperature. So in this case, we have a very low intensity of the urban heat island and a comfortable situation. I'm going to present, I don't know, because I forgot to start the timer. Sorry for this. So I don't know how.
You would have 5 minutes if you.
5 minutes? Okay.
If you manage to do it, okay.
Okay, I try. As a specific example of the measurement we did, I want to show you Prato della Valle. That is a very big, huge square in the center of Padova. That is 90,000 square meters of this square. I think this is the second biggest square in Europe, or something considering Russia in Europe, after the Red Square in Moscow. We did measurement, in situ measurement in 6 different points of the square, and this is interesting because we have different situation in the same place. We have different situation because point 1, for example, point 2 or point 3 or point 6 are in the asphalt, but for example, point 5 is in the gravel, near a fountain, so near water, and point 4 is on the green near water here. These are trees. So we are very different microclimate in near places. Here you can see some picture from some of the points. I'm going to show you the result of the measurements. And for example, if we look at point 5, point 5 is in the gravel near the water, or point 4 that is in the grass, we have a lower air temperature, obviously, because we have say an effect of a cooling of the air by the water in the case of point 5 or position 5, and due to the evapotranspiration of water from the green in the case of a position 4. So the interesting thing is to compare the mean radiant temperature that is related to the comfort people to the air temperature. In position 4 and position 5, we have a very different value of the mean radiant temperature, lower value of mean radiant temperature with respect to air temperature, while in the asphalt, so in the position 1, 2, and 3, we have more comparable value of the two variables. So this is reflecting in the value of the comfort indexes that is a higher 0.8, 0.6 in position 1, 2, 3 than in position 4 and 5. So this is interesting because some specific issues concerning the simulation tools, but I don't have time to go on the details of this. The simulation tool, the Rayman simulation tools, have some limits, say. So we could simulate the mitigation strategies, some mitigation strategies, but with this tool, only theoretical mitigation strategies. That is, mitigation strategies that concern the decreasing of the H to W value, and so the increasing of the sky view factor. So, for example, in this point between these buildings, these numbers are the 80 meters of each building. We measure, we calculated by the Rayman tool the mean radiant temperature. That is this column, and the comfort indexes, and we simulate the possibility to lower the height of buildings, so we limit the height of building to maximum 6 meters, or, for example, to double the width of the street, or to triple the width of the street. And all these theoretical situation have the effect of to reduce the mean radiant temperature from the actual case, so from 26 to 25 to 24 degrees, and so to lower the predicted mean vault of the physiological equivalent temperature, as you can see from these results. This is another case, another example from another point of the city. But I'm going to show you the last simulation, the last results with another simulation tool, that is EnviMet, because EnviMet allows us to simulate mitigation strategy, different mitigation strategies. So, for example, increasing the green, trees and vegetative cover, and using cool materials to try to mitigate the phenomenon. Here are some hypotheses and inputs of the simulation. I don't have time to go into details, but I'm going to show you the results. Here we take as an example Prato della Valle, and we simulate two different scenarios, starting from the actual situation, that is the one depicted in this picture. The three scenarios that we compare is the as-is scenario, so the actual, and two alternative mitigation strategies. So the green scenarios, could say green scenarios and cool pavement scenarios. We take as a reference for air temperature the air measured in the countryside, so during a day. This is the air temperature, and these are the simulation. The green scenarios consist in reducing the asphalt in the around the square and substituting this asphalt with green, so increasing the green and the trees. In this case, you can see here, I'm going to show you the result in terms of air temperature, mean radiant temperature, and comfort indexes in some specific point of the square here represented. This is the scenario, the actual scenario for the different point, and this is the green ground scenario. So for the same point, and then we have a third scenario, implementing cool materials. As you know, these are materials that have a particular thermal behavior. So in particular, they have high solar reflectance. So say and higher albedo than typical urban material, typical asphalt or other urban materials, and at the same time high infrared emittance. This means, because, as you know, typically absorbance of materials for the second law of Kirchhoff is typical equal to emittance. So that means that a typical material absorbs a lot, emit the same quantity of the energy that it absorbs. In the case of cool materials, they are made by particular materials that allow to reduce the absorbance of the solar radiation, so increasing the reflectivity of solar radiation, and at the same time they have a high emittance in the infrared range. So they can absorb low solar radiation and emit a lot of infrared radiation. So the effect is that these materials have a lower surface temperature, so they heat up lower than usual materials, and so this allows to limit the urban heat island phenomenon. These are other hypotheses, but the results are that, for example, for position 1, these are this is the air temperature, in blue the as-is scenario, in orange the green ground scenario. So we can reduce the urban heat island intensity from the blue curve to light blue curve to the dark blue curve. But in particular, in position 5, that position 1 is here, position 5 is here in the gravel. We have a higher effect of this scenario, and in particular, in position 5, we have a greater effect, a huge effect, positive effect, in decreasing during the day the mean radiant temperature. So the mean radiant temperature, so not the air temperature, is largely decreased by the green because of the evapotranspiration effect that the green allow. While in position 1 we don't have a similar huge effect. We have a positive effect, but not so huge. Okay, these are other results in, say, in more effective way. These are a summarize of the result, also with the scenario, the cool pavement scenarios. And please consider the mean radiant temperature that is together with the urban heat island effect. That is you can see that the urban heat island effect is decreased from the as-is scenario in both in the green ground and the cool pavements solution mitigation strategies in different ways for the different positions. The first table, sorry, is concerning the day values, so at 3 p.m., so during the afternoon. But during the night, we have the higher intensity of the urban heat island. As you can see here, 6 to 7 to 8 degrees. And so the most benefit of these mitigation strategies. So, okay, these are some conclusions from this work. We measure that also in a medium-sized city like Padova, there is a urban heat island phenomenon, and this is a very consistent phenomenon up to 7 degrees during the evening and the night. During the day, the effect is minor, but is also present in the range of 2 to 3 degrees Celsius. And we test different tools and different simulation tools and different mitigation strategies to propose some solution to decrease this effect. One result is, for example, that small green areas, but near to the point you want to reduce the urban heat island effect, are better than huge green areas in the center of the city. So diffused green areas are, in our opinion, more effective strategies to reduce the phenomenon in a diffuse way. Okay. Cool materials can be a solution because they allow to reduce in a very important way also the mean radiant temperature. Okay, these are some references from our side and some publication in international journals or conferences. If you are interested to know more about our work, our measurement, our simulations. So thank you very much for your attention, and I'm available if you have any questions or if I can answer, because I repeat, this is a work made more than 10 years ago, and I want to thank Pierpaolo Campostrini and Matteo Morgantin from Corrida that helped us at that time to involve us at that time in this work, and my colleagues, Professor Lazzarin and Professor Busato, that worked with me in this project. So thank you very much.
Thank you, Marco. Thank you very much. It is a study from 10 years ago, but still very, let's say, actual.
Yeah, I think it's still actual. Yeah.
Yeah. I don't know if there are questions.
I saw that the University of Padova, not our department, another department in the engineering school, allow a study on urban heat island. They mapped all the territory of Padova, of the city, and so they have maps of the air temperature at 2 meters above ground for all the different points of the city. So the University of Padova is, and with the administration, local administration, is still working on this.
Thank you for the information. Are there any questions or? Or maybe we stay for, yes, we have one question.
No,
please.
More than a question is a comment after saying thanks again, Marco, for his kind availability for this extensive, very comprehensive explanation about the work we did together. some years ago, but I mean, it means in this, I would like just to comment to take this experience in this context of this project, where first of all, the comment is that about this kind of phenomena, the real, it is necessary to give quantification to the phenomena. So we have to make measurements. So otherwise, it is still a blah blah. So concerning also the climate change, the effect or the different effect of climate change in the cities and elsewhere, we need to give a quantification of the phenomena. Otherwise, you cannot manage what you cannot measure, as economists said. But also in this case, we do have concerning the urban Italian phenomena, the first step is make some figures, some data, which because not all the experiences can be easily transferred from one place to the other. Then the second comment is that solutions are possible. Most of them are quite simple. Among the simple measures, the nature-based solution are the best one. So I think that also and this applies not only for the, let's say, new expansion of the towns, of the cities, So if you have to plan a new quarter outside the city, now it is relatively easy, to think about some criteria which are already written in books. But the experience made in Padua is that also in the already built city, maybe that which have been built as most of the city, unfortunately, without taking into consideration these criteria for having considering also the problem of eating, of albedo, of the presence of quantity of biodiversities, but it is possible to do something. And I would like to connect this to the new rules that at least in the European Union member state it is a rule. So the rule to consider also urban ecosystem in the restoration, what is called the restoration law. Also the urban ecosystem must be assessed. And in the urban ecosystem, the problem of urban Italians is one which can be really assessed through some easy but not trivial intervention for reducing the phenomena. So we do have now the means. We have, as Professor Noro shown, the tools for understanding, to measure and to quantify the phenomena. So we have also, for European member state countries, an obligation to do it for the restoration of our urban ecosystem. Okay, this is just my simple comment. Thank you again, Marco, for your kind intervention tonight.
Thank you. I perfectly agree. Thank you, Pierpaolo.
Okay. Maybe we shall move to the next presentation. So introduce you Professor Emanuele Naboni, very international professor. So now he will present himself because he has a lot of affiliation that I don't remember. Thank you, Emanuele.
Okay. Hello, everyone. Can you please confirm you're able to see the screen?
Yes.
Yes.
Okay, great. First of all, thanks so much to Professor Francesco Musco, to Professor Davide Longato. It's a pleasure to join you, and also great to get to know about the Adrian Nature Network. It's really an interesting initiative. We'll be talking about heat, and I was asked to talk about the nature-based solution. It's part of my research. It's not, it's, let's say, one leg. Just a bit about myself. I worked primarily at the Royal Danish Academy and NTNU in Norway, University of New South Wales with Professor Santamouris. Also, I'm affiliated with UC Berkeley. And as a consultant, I work for Atkins Realis. I'm collaborate with the World Health Organization and European Community. And I'm an academic at the Norman Foster Institute. It's a long path coming from ATH, APFL, Architectural Association, but I spent several years at the Lawrence Berkeley National Laboratory in California. And I have my practice as a consultant for projects. But this comes from a few years at Skidmore and Merrill in San Francisco, and my doctorate was at Politecnico with 3 years spent at University of California. I consult on this topic globally, so I have several ongoing projects on the topic of heat, and I hope to share some insights on the topic. We operate, or the topic of, let's try to shift from I to what it's remarkable for you. So the meaning I want to address are related to 3 scales. The one of planning, how nature-based solution and heat goes hand in hand, and buildings. So we'll show some example where nature-based solutions are included into that. Perhaps this is not the most representative example, but it's the Burj Khalifa, perhaps one of the first building I had the luck to work with. And small prototypes where we take, let's say, contents, natural contents, and we try to get them tested against or in the adaptation with climate change. Okay. Most of these contents, for those that are interested, are in this book, Regenerative Design in the Digital Practice. And this can be downloaded in ResearchGate or in the website of the Royal Danish Academy. Okay, so first of all, about the approach. We know that there is a strong degeneration of the ecological layer, a strong carbonization, and there is a decrease in health. And we know that business as usual will continue the process. We know that if we will mitigate, we will more or less keep the status quo. We need to probably think of a strategy that is not only resilient. Resilient means that after an event, a climate event gets back to its status. And it's probably in between adapt and regenerate. It is about create a new link between the built environment and the natural environment that thrive, that give a major ecological health, that gives, that decarbonize and produce health. So if we look at the status of these 3 variables, of course, there is a process of degeneration, and a sustainable approach will actually conserve it. What we need is probably to establish a new collaboration between the built and the nature-based solution. Also, nature-based solutions are often conceived in an opportunistic way, where they are something that provide a service to human. But what emerged from all the research I will be showing is that we need to protect nature first in order to create the asset and all the axis of contribution to our health. So we have to shift our design from human to nature, and this will be shown very soon. Of course, this is strictly related to climate change. We know of implication of small degrees changes into carbon, ecology, and health. I will leave this slide so you can get through these, and these are backed up into literature. And the lecture of today will range from an extra scale, let's say the new planning of a 20 square kilometer area, to the micro scale of technological components. First of all, when we look, and this is a tool we are developing along with this will be an available tool representing climate change at different location. But what we see, first of all, that climate change happens differently from area to area. This is a delta from 2014 now for different cities. We can see in certain city, like the northern one or the Central European one, like Vienna, in most of the cases, what is happening is that we have heat waves and cold waves. When we talk about Italy or going south to Riyadh, there is a flattened increase of temperature. So this means that people, ecological system, buildings have different type of inputs. They have to adapt to different patterns, and this requires a very calibrated local type of approach. There are certain codes we develop are very simple, but we used to understand according to the site, getting from agency, let's say, starting factor, we can understand in a very simple way what are the trends and how and where it's possible to control heat into the environment. I don't like to call it heat island, and I will explain later. But the first project, ongoing collaboration with Riyadh, this actually looks like a desert. The only trace we have into the ground are these lines that are dry river. They're called wadis. We're planning all this area, and we act as sustainable consultant. Also, this will be the largest building in the world with the one you can see in the center, with a side of 500 meters by 500 by 500. So the conception of this place is that the first infrastructure that is taken care before the built one is the one of this natural belt. These are those pockets grant certain area at lower temperature and allow for certain thermodynamic exchange with area at a higher temperature. The shape is also given, and the turbulence given by this big giant building that is going to be the largest actually globally, is that it creates turbulences that taps like more or less like the fan coil of this area of 20 square kilometer, where there is an acceleration. And when we talk about outdoor comfort, wind up to 36 degrees up to the body temperature, it's a big fact, is a strong factor. Even 2 degrees below our temperature is still contributing to a certain quality of comfort. But what we project for, it's primarily the comfort of different species on site, and human comfort come just after. There are also qualitative aspects. For instance, for each of the districts, we have a certain relation to nature. Each of the individuals have to establish a personal connection to the site, is also called biophilia, and this can be indexed, of course, into the development. But let's get back to something close to our network. These are studies in Sassuolo and Maranello together with Mario Cucinello office, where we use a pixel approach, where we put station on site to understand and to calibrate models. We have models that come from the city center to the agricultural or even natural areas, passing through the industrial one. The models are for the city center. The models are also combining the outside and the inside. We can see certain interesting behaviors between outside and inside. But I wanted you to focus for a minute on this slide. These are the different areas: city center, suburbs, industrial site, forest and rivers, and agricultural site. If we look at the temperature in 2050, we begin to understand that the temperature that gets at a higher temperature can be those that are agricultural, and those that, for instance, are forested. When we look at the increase of temperature, and this square perhaps helps, the area that are increasing the most the temperature are those that host today vegetation or wildlife, all the living system of the city. So it was very interesting to assist to the presentation earlier of Professor Noro. And what I can say is that that gap between the outside and the inside is already nullified today. Most of the times we have higher temperature on the outside of the city than into the city, or at least we have today a similar temperature. And by 2030, we are going to have, let's say, around the city higher temperatures convert as an opposite of what it happened into the center. We can see how the increase of temperature within the thermal massing of the city are about stable, but to the outside there is a high increase of temperature, and this is because species degrades in the sense that amount of water, radiation, and temperature gets the plants outside of the comfort zone. Then they dries or they dies or they summer hibernate. There are different strategies, but the plants change the structure. They increase the local heat, the albedo reduces. So, and this is a trend that we are seeing in all the modeling of the natural and living system. Consequences on site are very high. Obviously, we model data from the Regione Emilia-Romagna, and try to understand with our localized model what is going to happen. These are profound implications, of course, in pollen concentration and in phenology. So the meet between vegetation and pollen. So there is a big decay of pollen insect as well as of pollen concentration. And we know how hard this is for many layers. But implication are obviously due to the, let's say, degradation of nature on pollutants as well as an increase of respiratory diseases. We know also that plants aren't exposed to their crisis. They emit natural VOC that are actually worse than car VOC. So something to but already move the focus not to protect and perhaps understand how we can shade this area, how can we implant new type of species, how can we create buildings that shade nature, whereas rather than think of nature shading us. Nature in future to shade us will have to be shaded by some other type of artificial elements or some intertwining between species. This is something already present, for instance, into Arabic gardens when species are put together to get a collaboration. But this work is for the city of Gothenburg, where actually there was a decision to be made on what to do about large areas that were very interesting in terms of expanding the building stock within the area. And for each, so we created a model where for each living system or this primary one that are in the area, we can track carbon, pollutant, local temperature contribution as well as biodiversity support. This in light of climate change, understanding how temperature are shifting and creating what is perhaps the largest full thermodynamic CFD model with actually 2 kilometer by 2 kilometer with micro resolution, where there is actually coupling between each building. Each of the plants are modeled for their functioning as well as of the sea. So that led to very interesting consideration. First of all, that the buildings that are performing best are those with less isolation that are into a natural context. As if we begin to think that plants, an average plant equals 4 air conditioning system, and if we begin to think of considering the natural plants in both seasons as an isolator, we need much less insulation into the buildings, and we can get to very good temperature within the inside. And this is amplified, this collaboration within nature and buildings into the building of 1960s, that at night reach the lowest temperature and during the day basically a very similar, let's say these are heat energy flow, but temperature curve are very similar, a very similar curve of hyper-isolated buildings. But the buildings that are isolated never cool down at night. So this is a big problem of all passive houses, even in Italy or even in Vienna, where houses today are basically not usable from May to September because temperatures are very high and there is a thick pullover that you cannot get rid of into summers. Although you may have cross ventilation, it is a law that we record in many buildings that we measure, like these ones, but many others. When you put insulation into the building, even if you have insulation, will never cool down as one without, with significant differences. But the work starts from earlier studies in a PFL, where I was for a few years working with Professor Scartezzini and others. Great times, or try to understand how to create a plan of climate adaptation, working with some primary architects. And we soon end up understanding that we have losses from building that contribute to local climates, but also that temperature into context, the one that we measure, and then we calibrate some model, are too high. So we need to have a decisive type of resurfacing, as well as we have to design buildings, and especially the new one that I will show now, that let breathe in, and that they are cooled down by new material into the context. And this, of course, is a larger plan. But what we could see is that the building that cool the best now and still keep performance in 2039 are those with slightly less isolation and when are surrounded by vegetation, not primarily for the shading, but also for the temperature of the plants. But there is a nice integration between plants because they're shaded by the building, and this cools down and reduces the cooling loads by a significant amount. So some of the building, like this one with the Kengo Kuma, it is about having an extended cantilever, of course, to protect from low sun rays, because with climate change, what is interesting is that we have to protect building much more into the facade. What changed with the change is the radiative income. By 2100, if we continue as business as usual, each watt of our buildings, cities, and our body will be enhanced by 8.5 watt per square meter of any surface, including our body. And already in March, temperature is high and the sun is rich of power. So we need to extend. For Rome, for instance, cantilever at the south side should be extended of 15 centimeter, according to the basic law of what an overhang can be at south. But in this case, the building collaborates also and create this buffer where vegetation that now is grow really give the performance of the building, and where we can obtain in summer with no mechanical system lower temperature than those that we would have if we have an enclosed building with no collaboration with the outside. So this is something to consider, but also the building has to offer to the site. It has to offer channel for ventilation so that the site can cool down. So it's a mix of factors. I misbelieve when there is a reductionist approach to a city strategy. And primarily this is oftentimes about cooling material, intelligent material, subambient temperature material. These are really interesting. They give a great baseline for comfort, but it's very important to create a mix of strategy, not just have one strategy fits all and taken from out of the shelves. It needs really to be studied locally. Strategies are hyper local, and some that work 20 kilometers away will not work in another type of content. Collaborating with Shinozuki to the Lavazza headquarters, and with the intention of create an ecological structure that create wildlife that retain water, have different water flows. It has become immediately evident when you begin to model each species. And when you try to have some future projection of temperature, it becomes obvious that the temperature reduction, the performance of temperature reduction that we track over several projects are not effective above certain temperature. We know that already above a certain temperature, water become a negative feature, but we know also that plants and specific plants that were discussed with landscape are not effective anymore. They dry, and in some cases, for extended dryness, they die. So it's very important to think of that, I believe. And we do this with some script. These are applicable to all cities. So these are customized and we can input or also customize according to the species, understanding what's the local type of performance, and then begin to impact the design of the landscape, as there has to be, is not a matter only of surfaces or of evaporative transpiration system until a certain temperature. It's about geometry, and geometry is one of the big parameters. Shown an example of a project for building in Milan, where along with the School of Sustainability, and this will be housing. As you know, there is a big issue with student housing now in Italy, and there are a lot of calls for this. The overall concept here is to use certain scripts in order to start from vegetation at the center of this diagram, where we understand what is the millimeter of precipitation and context. We understand what is the radiation that comes from sun. We establish threshold according to species of what is the maximum radiation and the water that is needed according to temperature profiles. So in the balance of these three factors, geometry comes to a play, because only certain areas will allow to have plants that do not require intensive irrigation and will stand heat waves in Milan. So this is a simple script, and also there is one for wildlife with different parameters. One, of course, for outdoor temperature, but also qualitative aspect and as in context to nature. So, for instance, how much nature we can see as citizen when we or occupants when we have that exposure to nature. Building form is very important because the amount of area that are into comfort dramatically changes according to shape. And also when it comes to biodiversity script, these that are targeted to the parameter I mentioned earlier, what we can see is that each massing grants or more or not, like in this configuration, there is very minimal area that can be used for vegetation. But if we begin to create certain proportion and having, for instance, a roof over here of a certain kind, we can increase very much the space for nature-based solution. We can plant as many trees, sorry for the iteration, as many trees that we want into the city, but they're not going to be survived if they are into these black areas. Even including them as a sharing system, we can see that there is no condition for them. So that is what comes out. And then when we go into more complex, let's say coupled model for outside and inside, we can see also how vegetation within the development influence also local temperature. And that is why all these envelopes are studied to maximize these thermodynamic exchanges between the outdoor and the indoor. The program, of course, needs to be customized towards this type of activity. But an interesting intersection is with CO2. Nature-based solution, CO2 cycles, programs are very interlinked into a strategy for CO2 nullification or decarbonization. Just to explain, when we design, I really wanted to incorporate also a little bit of this branch of topics, although it's another chunk of work that is developed apart, yet talks to that. When we design a sustainable building, there is a CO2 emission for construction, certain for maintenance, operation, heating, cooling, and so on, management, and so on. And this can be referred to a district. It doesn't have to be related to the building. When we design in a regenerative way, with the aim to have always a positive balance on all axes, actually we can already create a carbon negative building. There is anyway some operation of maintenance that is needed. The more the material is bio-based, more maintenance is needed. So it's primarily maintenance. And if you well design, also there is, of course, a very minimal cost for, let's say, CO2 emission for operations. But within this picture, nature-based solution will never be effective in the goal of reducing and nullifying emission. In all projects I've seen, the best proportional, even with very densified of nature-based solution project, the build emit always 15 to 20 times what nature can absorb. So, but if we are able to design something with this characteristic, then we can reach this balance where actually the little emission of a certain project are then shifted by nature. To pursue these scopes, we have developed a very simple script. This allows for fast calculation of the emission in construction, in operation. But where I wanted to focus on is on the carbon extraction of the ecological layer. So it's possible to understand not only the contribution, let's say, to heat. This is something that it's established. We can today very well understand how nature-based solutions contribute to, let's say, the thermodynamic and the heat into a context. But when we begin to expand the co-benefits, of course, we can understand by species, by location, by exposure to different temperature, what will be the carbon emission. It's clear, of course, that there is a geometry also of leaves, and larger leaves absorbs more. It's clear also that certain plants stop absorbing CO2 in summer when they get dry. So in this case, certain of the performance are minimized because the plants may suffer during this season. So there's a complex articulation of matters, and you can see how decay in CO2 performance corresponds then to decay into heat management into the context. Very interlinked, and this script allows us to really understand what are the contribution. Perhaps I will skip some Danish example, but operating in Denmark on certain basis, there has been a strong process of naturalization, especially after the big flood of the 2010. And space like this became like that. A long story narrated in 2 slides. But what we soon understood is that it's interesting to design, and this was a collaboration we established with DTU, establish how different parts can absorb different type of water, and water kept inside leads to very different performance. And these performance are on a first layer, as we can see here, accounting it or not, gives very different results in terms of, let's say, local universal thermoclimate index, in case we want to refer to an index. But this also gives a certain differentiated pattern into the energy behavior of the surrounding build. So it's very interesting to consider how to retain water as well. Change of scale, so we have shift from medium to small. It's also worth mentioning that vegetation is not always the best active solution. These are some works we are doing with the city of Parma. This is actually for the acclimatization of courtyards, where we soon understood that the major issue into courtyards is, first of all, the lack of ventilation. Most courtyards used to be conceived with open side for ventilation. These have been closed in order to increase the volume, usable volume into the building. But the issue is that also the side of the courtyards, it's up very much. So what we end up is to establish a system that allows for ventilation but shade primarily the facade, which are those that reflect the wind. So there is, of course, short wave and long wave that have been manipulated by this system through a set of algorithms. But we started wanting to, for this courtyard, which is a cluster, technically speaking, we wanted to start with, let's say, a small forest and water. And this also only came up as a later strategy, as a benchmark, but then we can see that we can have very much better strategy. So this is a typical day, and this is the perceived temperature, universal thermoclimate index, to simplify for non-expert. What we could see over the 24 hours is that we have much lower temperature into summer peaks, having a shading system than a nature-based solution with water and vegetation. Water, when evaporates, creates enthalpy. Water is high, is not ventilated, and then it has a certain property that becomes counterproductive above a certain temperature. Vegetation as well gets dry a little and lose part of the performance. Actually was not full decay into the courtyard because the courtyard yet offers some performance. Ventilation, it's interesting, but with climate change is less and less interesting. We have to have and grant air movement, but the problem is that ventilation over a certain temperature will be a problem, because it's like having a phone dryer and hair dryer actually in a trajectory of our body. So obviously, if temperature is higher of our body, actually we warm up because we have an exchange of temperature with ventilation. So it works, it's still working, but I predict that in 20 years will be a problem to use natural ventilation, even for buildings. Very small scale, and these are prototypes developed. We have 300 of these, where we try to understand living system integrated into buildings, how they can be integrated. These are the typical drying. Here we work in the Faroe Island, try to understand what is the alteration of the microclimatic variables, of drying fishes. But we have several examples, more than 300. You can access them on the website of the, it's called Architecture in Extreme Environment on YouTube. I act as a scientific responsible there. The director for correct accreditation is David Garcia. And the overall scopes here are the one of understand how, into different contexts, we can capitalize on climate change. For instance, these are some works by a student. This is a short work. It's probably a work of 1 month in Copenhagen, and then students go on site. And these are extreme climate where already heat or climate changes have happened already. Working in Morocco, we had 25 prototypes, and I'll show this one by the student Magnus, that create a system able to use the excess of CO2 release into city, in this case is Casablanca, use the water that comes from the air conditioning system, and capitalize on clay, which is largely available material into context. And so clay is obviously a very strong material. So this system, it's meant to be a facade that grows tomato and also cool downs the building as well as the context. So in what we could see is that as compared to a non-polluted area, tomato grow is much higher. And this system that it's living and is only plugged and it only has a small passive ventilator included into it. But within the area, it's possible to obtain a small reduction of CO2. And it's possible with this technology as well as and this is how it can be plugged, and it was tested and measured. And the growth of vegetable is much amplified by this type of technology. So there is ample room to understand how the negativities of climate change and pollution can become a resource. This means to regenerate, to have an approach which is about to create an alliance with the factor of climate change rather than achieve only a matter of mitigation. Another example, this was a collaboration when we went to Alaska, and this was with NASA. It's about using the happening of the permafrost melting and using the genetic components, the biocomponents that come from it for photobioreactor. And these are small technology that allows for small environment as those of Alaska that are very enclosed, where you open seldom doors and windows in order to conserve heat, and where there is a very much lack of vegetation. To use a bioproduct, and I will skip for the sake of time, like purely like, melting permafrost into these, let's say, systems that allow to create a certain temperature within context, which is actually higher than the surrounding cold means. So it becomes a warming system in a season, it becomes a cooling system in another season, but also it allows for absorption of CO2 and creation of other feedback. So these are small tests that begin to develop strategy that then can be scaled up into further application at a much larger scale. Okay, so conclusion. First, as said before, there is a very interesting moment for cities, and there is also a strong direction all over context to greenify and to forest and toward forestation of city, although this is often done with no knowledge. So it means that we are creating something that may be a negativity or something that will stand for a while, but it's probably something that will create a negative output unless it's well designed and simulated. Second, but we probably need to stop our opportunistic view of nature-based solution as something that provides service to human in order to adopt a conception of design for the system. So understand how we can place the system, how we can plan the city or plan the outside of the city to have a nature that thrives, because it's well protected from primary forces of heat and vegetation. Third topic, it's that we should not talk any more longer about heat island as the area that will be at higher temperature will be those that are natured. And even within the city, natured parts will become a threat. They need to be really designed well. And I guess this summarizes more or less the context. It would be great if we are in contact with all of you. The content in LinkedIn is Emanuele Naboni. And in case in Instagram, I attempt to post some of this work, or will do soon, Emanuele_Naboni_climate. And I hope we can stay in touch. Okay.
Thank you. Thank you very much, Emanuele. Okay, we are a little bit late, but I don't know if there are some interaction with the
I did my job. I
presenter.
stayed enough an hour.
Yeah, yes. Yeah, definitely. Questions, curiosities from the audience? Maybe I have one.
Okay, thanks.
For you, but also for Professor Marco Noro, for all. So from your presentation, seems that okay, nature-based solution. If we strictly see nature-based solution in terms of cooling potential, maybe not always the best solution. So what is, let's say, the balance in the decision that we need to consider? Because of course, nature-based solution can be not always the best solution, but has a lot of other co-benefits that maybe other type of solution that are very, very effective in heat reduction. I'm just cool materials or shading structure, but do not provide the other co-benefits. So it's kind of compromise that is, if I can repeat something that you already say, very hyper, let's say, hyper local, no? So each project design need to be decided based on the very local case, on a very local case. So I don't know if you have some insights about this, so about co-benefit balance, compromise that need to be taken, especially for public officers that propose and follow this kind of planning purposes and design purposes.
Sure. Super holistic question. I love it. So the matter is that nature-based solution offer a great nuances of benefits, and we can model them. We see them into the model. We try to measure them when possible. On the other hand, these are the most fragile layer. The built environment is much more stable, and we'll have a better acclimatization to the changes of climate change. Nature-based solution, therefore, needs to be designed. Actually, it's very important to design the environment for nature-based solution. So create sort of indexes of comfort for everything that lives. That will be the primary asset of future planning. What I see here in Milan, where I'm today, or when I travel around, is that they are placed according even to interesting designs. But the non-understanding that the hydraulic flows are changing, the non-understanding that radiation increase every year by about 0.something watt per square meter. The non-understanding that temperature are rising make them often having a short life cycle and or underperforming. Nature-based solution only acts well when they are in the best shape. So the the data that I have at hand says that in Europe, 1/3 of the nature-based solutions are suffering or underperforming. And it's incredible to me to keep listening to presentation where nature-based solutions are considered as the panacea of every bed, because with not an accurate design, they are underperforming or negatively or becoming a negative side of a project. When we, in often case, when we see vibrant vegetation in other climate, there is a huge, tremendous effort in CO2 due to maintenance, and there is a huge amount of water that is used to keep them. So the picture may look good, but when we look at the data, the hydraulic data and others, we can understand that behind there is a huge imbalances that create then a problem in the next area. So it's my suggestion. It's always to think systemically and understand the full chain, and primarily it's to understand that thermodynamic of plants, it's the determinant factor. Only up to a certain, let's say, a house for them, they can perform well. Then they will be neutral, and then they will become negative. So as I was asked to talk about heat and nature-based solution, I think this it's the shortcut. So the big advice, it's to understand how to design them. It's not just about placing them according to an interesting design. There is a very complex design. It's not complex actually, but there are a few parameters to be taken into account. Yeah.